find the absolute extrema, that means absolute maximum and absolute minimum values of the function, this function, on the triangular region R. This is the triangular region with vertices 0, 0, 4, 0 and 0, 4. So we first find the critical points of this function inside this region, okay, and we evaluate the function at those critical points and at the boundary. Boundary means this line segment L1, 0 to 4, this line segment L2 and L3. Okay, so let's find the critical points. For we find partial derivative with respect to x and partial derivative with respect to y. So with respect to x, so this is y minus 1, 0, okay, and 0, so y minus 1, and we said that equals 0, so y minus 1 equals 0 implies y equals 1. Similarly, partial derivative with respect to y, just x, 0, with respect to y, negative 2, and we said this equals 0 as well, that gives x equals 2. So we have 2, 1. 2, 1 is a critical point, and we need to make sure this point lies inside this region, and in fact 2, 1, yes, it's somewhere here, 1, 2, 1. Okay, now we evaluate this function at this critical point. Okay, so the function value at 2, 1 is just plug in x equals 2, y equals 1, so 2 times 1, 2, minus 2 times 1, 2, plus 2, and this is just 0. Okay, so we got a function value 0 at the critical point. Next, we need to evaluate this function at the boundary, okay, at the boundary of this region. So L1, let's work on L1. On L1, we know the equation of this line, which is x 0. So x is 0 on L1. So this function f of x, y is in fact f of 0, y, because x is 0 on this line segment, and f of 0, y means this function reduces to x is 0 times y, 0 minus 0 minus 2y plus 2. So this is just negative 2y plus 2, and y runs from 0 through 4. 0 through 4. All we have to do is find the maximum and minimum value of this line segment when y runs from 0 through 4. We don't have to find every single values because we are just trying to find the maximum and minimum value. And this is negative 2y plus 2. Clearly, if we plug in 0 here, 2, that will be maximum value. And when we plug in 4, negative 2 times 4, negative 8 plus 2, negative 6, that will be the minimum value. And we don't have to find all other values. So here maximum value is at 0, because this makes y 0, just 2 at y 0. In fact, x is already fixed 0, so at 0, 0, that means at the origin, at 0, 0, the function value is 2. And minimum value is, if we plug in 4 here, negative 2 times 4, negative 8 plus 2, negative 6, and that is achieved when y equals 4. In fact, the point is 0, 4. 0, 4, that's here on the top. Okay, so L1. Similarly, let's work on L2 line segment. So it's along x-axis. So y is 0. So the given function fxy is in fact fx y value 0. So the given function reduces to, with y being 0, y 0, so negative x plus 2. Okay, again a line segment. and on L2 x ranges from 0 through 4. X ranges from 0 through 4. So we want to find the maximum and minimum value of this negative x plus 2, which is a line segment, and max value we can just find, just from observation we can find max and min, because 0 makes 2, that's the max value, and 4 means negative 4 plus 2, negative 2, that's the minimum value. So max value 2 at x0, and min value equals negative 4 plus 2, negative 2 at x equals 4. In fact, this maximum value 2 is at x0, y is already fixed 0, 0, 0, which was already found here, 0, 0. Okay, so this is just redundant. And minimum value at negative 2, at x equals 4, y is 0, so 4, 0. So we found the value here as well. We already found 0, 4 on the top, 0, 4. Now on L3, L3 is the line, we need to find the equation. Okay, this L2 was easy, just y0. L1 was x0, but this is a line segment, but we can find the equation of the line. Look at the slope of this line. It's going down means slope negative, so rise over run is kind of fall. Negative 4 over 4, so slope is negative 1. So the equation is y equals mx. M is negative 1 x, negative 1x, plus b. B is y-intercept, that's 4. So y is negative x plus 4, or 4 minus x, same thing. So the equation of this line is 4 minus x, and the x runs from 0 through 4, by the way. In this case, x goes from 0 through 4. So on this line, our function a of xy becomes this given function. Replace y by 4 minus x. So x times y, 4 minus x, minus 2y. Y is 4 minus x plus 2. Let's simplify. This is 4x minus x squared minus x, negative 2 times 4, negative 8, plus 2x plus 2, which is, let me write here, negative x squared, highest exponent first. Here is 4x minus x, 3x plus 2x plus 5x, and negative 8 plus 2, negative 6. So our function becomes a parabola. Negative means it's opening downward. Now we need to find the maximum and minimum value of this function, which is essentially this function, when x goes from where? 0 through 4. Because the x is changing, only x is here, and x is going from 0 through 4. It's like pretty much a calculus 1 question. And how do we find absolute maximum and minimum value of this function? We find the critical number of this function and evaluate the function at the critical numbers and at the end point, 0 and 4. But 0 and 4, 0 means here will be the point, they are already evaluated, so we don't have to do again. Because if we go up, here is 0, 0, that's already done. 4 means 0, 4 is done here as well. And we have x0, okay, y is 0, x4, 4, 0 here is done as well. So we don't have to worry about 0 and 4. We find the critical number of this function and evaluate the function at that point. And that can be our maximum or minimum or nothing, we'll see. So if we just find the derivative just for this one, regular derivative, because we have only one variable x, that is negative 2x plus 5. And when we set this equals 0, let me write this equals 0, that implies x equals negative 5 over negative 2, negative, positive, so 2.5. Now we evaluate this function at 2.5. Okay, let's use our calculator. f at 2.5. By the way, we don't have to worry about y, there is no y mentioned. Minus 2.5 squared plus 5 times 2.5 minus 6, which is, this is positive 0.25. okay, and that happens at x equals 2.5, and y is in fact 4 minus x, so 4 minus 2.5, so at 1.5. Anyways, we are only interested in finding the maximum, absolute maximum and minimum value. So here was one value, 0, and here was 2, here is negative 6. On L2 we had 2, same, and negative 2, and on L3 we just found the critical number here using calculus 1, and we found the value here. We were supposed to evaluate this function at the endpoint 0 and 4. Here at 0 and 4, that means pretty much here and here, they are already evaluated, so we don't have to worry about that. And the maximum of all these numbers is absolute maximum. So absolute maximum is, where is the maximum? 2. That's 2. That's the biggest number. And absolute minimum is negative 6. So if you want to write down the location where they happened, so maximum 2 is y0 x0 at origin 0 0. So pretty much here 0 0. Absolute minimum, that happened at negative 6, that y4 x0 0 4. In fact, okay, 0, that's nothing, neither maximum nor minimum, same thing here. Okay, final.